All right. So I'm going to put up a set of data here, and I want you to do an F test and a T test to tell me a little bit about this data. All right, so there's two methods. Okay. The first method, the old method, gives us a concentration of 24, let me put average, x bar 1 equals 24.4 picograms per gram. And average for method 2 is 42.9 picograms per gram. The one with a smaller average also has a smaller standard deviation, 3.6, whereas the second method has a standard deviation of 4.6. For both methods, we have 6 data points. So we're going to figure out two things. The first, are the standard deviations statistically similar? What test do we use for standard deviations? T or F? T or F? F test for standard deviation, right? And for these number of trials, F from the table, I looked it up for you, is 5.05. For number 2, are the means statistically similar? And now that depends on F, which t-test we have to use, right? But we need to use a t-test, and T for the table is 2.571. So I'm going to give you just a minute to work on that. That test is a real quick one. So what do we get for F?
1.63.
Yeah. Now why did I put 4.6 on top if that was S2?
Larger.
Yeah, the large one always goes on top. So F calc. F calc is less than S table. So are they statistically similar? Yeah, so we can't remember whether it's greater than or less than, right? Let's just think this through. If these were very different, would this ratio be large or small? It would be large, right? If they were very different, the ratio would be large. If they were very different, then they're not similar, right? And so if it's larger than the table, it's not statistically similar. If it's smaller than the table, it is statistically similar. And so the answer is yes, they are. And so this, remember, this tells us that, okay, if our standard deviations are similar, statistically similar, then that means that the 6 trials that we did with method 1 and the 6 trials that we did with method 2 could come from the same population. Right? That's what this is telling us. It's telling us that the spread in the data for method 1 and method 2 is close enough that we could think about the 2 sets of data, method 1 and method 2, coming from the same overall population. All right. So if it passes the F test, what kind of t-test do we have to do? There were 3 kinds. We have to do the pool. Okay, we can handle it. We can handle it. Okay. S-pool, you'll always have these equations. You do not have to memorize these. And remember, I told you, on an exam, there's a good chance I'm not going to ask you to do this. S1 squared, 3.6 squared, times n minus 1, that's 5, plus 4.6 squared, times 5, divided by 6 plus 6 minus 2, that's 10. And then t-calc, well, let's figure out this pool first. What do we get? Say again?
Oh, never mind, I see what I did.
Okay.
I was thinking of the experiment that it was 10 minus 1.
And so when we pool our standard deviation, most of the time our standard deviation is going to be somewhere between standard deviation 1 and standard deviation 2, because it's the standard deviation for the whole data set. So when we pool these together, again, we pool them because the F-test tells us, yeah, okay, they're from the same data set, they're from the same population. So we pool them together, and hopefully our pooled standard deviation is between 3.6 and 4.6. 4.13. Okay, and then our t-calc is another big equation. It's the difference between our 2 means. So the absolute value of 24.4 minus 42.9 divided by S pool, 4.13, times the square root of the reduced number. So 6 times 6 is 36, divided by 6 plus 6 is 12. So, 42.9. here. Yeah, 7.76, and so T count is greater than T table. So are the means statistically similar?
No.
No. We can almost have said that just looking at it. I mean, it's almost double, right? But we want to have some statistics to back it up. Usually, to pass this test, if the standard deviations are similar enough, then these two have to be within 1 or 2 standard deviations of one another, right? So the pooled standard deviation was 4.13. So if this were within, maybe 4 or 8, 8 would be 2 standard deviations. If these were within 8 of one another, we might have passed this test, right? But they're 18 from one another, which is more than 3 standard deviations for either one. So no, the means are not statistically similar. Something's up. Okay. Does that make sense? Looking through that? Okay. All right. So, oh gosh, they wash these with some kind of cleaner and it leaves the residue. And then you pass this over it, and the cleaner picks up whatever's left on the eraser. Maybe it's not bad from where you are. That was also a lot close. Anyway, so then the last statistical tool that I have for you is the Q-test. And to talk about the Q-test, we really need to talk about outliers. So when we are looking at outliers, I just realized that this video is flipped. I'll flip it in post. That's okay. So outliers in our data set. These are data points that likely lie outside the standard curve for a given data set. So again, remember we're talking about this Gaussian curve. So if we know our average is here. We have lots of data points that give us that average. And then there's this one data point that's like way out here that sort of pushes our average higher than we feel like it should be. We're gonna try and see if that's an outlier. And we do that using this Q-test. So the Q-test is a test for outliers. And what it looks at is it looks at how far away is that the data point that you think is going to be an outlier. How far is it from the rest of the data? And so one thing to keep in mind is that if they lie outside this standard curve, we can only look at the highest and the lowest values. And if they're in the middle of our data set, it's not going to be an outlier because you've got a data point on either side. It's only going to be those data points that are very high or very low relative to everybody else. And so when we calculate Q, it's the gap divided by the range. And So I'll give you a quick definition, right? The gap equals the difference between the outlier and the next data point. Okay, absolute value between the outlier and the next data point. So in this situation, right, it would be this guy and this guy. We're going to test that gap. And then the range is the highest value minus the lowest value. And until we throw out that thing that we think might be an outlier, that outlier is either going to be a high value or a low value, right? We have to include that value, that data point in our calculation. Yeah.
For the gap, you put plus the next data.
Oh, I did. I did do a plus.
I was getting nervous when you did that.
Because you just did it 5 times, sure you have. Minus. Yeah, we're looking for that difference. Okay. So, that's the end of chapter 4 stuff. And what I have is a worksheet. This worksheet has a couple things going on. On one side, it has a couple of practice problems. First of all, I'm not going to collect these worksheets. These worksheets are for you to practice, for you to study. This first question just asks you to put confidence interval in your own words, in order to describe what a confidence interval really means. The second one is a multi-parter that gives you some data and asks you to analyze it. And so, when we remember, there's 3 different kinds of t-tests, and so we're going to have to sort of determine which type of t-test we're going to use, and then go ahead and run it. Okay. On the back, this is, it's not from last year, but it's from a few years ago, the exam 1 equation sheet. I changed books, and so I don't know if we'll get to the exact same spot, so I don't know if we'll need the exact same equations, right? But this is what I gave them a couple of years ago, so this is what you might have on our first exam. Not only does it have all of the statistics stuff, this one has a lot of activate equilibrium stuff on it as well, but it has the F table and the P table down at the bottom. Now, I encourage you to be socially distant, but I also think that to work with your ears. So, as distant as you can, work with one another, check your answers, make sure you're understanding what's going on.
What kind of paper is this?
This is legal size paper.
You're like, oh, that's